Sensor components are transducers that convert non-electrical signals into electrical signals. In this lesson video, we're going to look at one of those. We're going to look at the strain gauge. You should have covered strain before while learning about the Young modulus. It's the extension of a material divided by its original length. So, a strain gauge is going to be a gauge, a tool to measure, extension of an object. This picture shows a simple way to do something like this. This lighthouse has a crack in the foundation bricks, which is fairly normal really. Cracks are impossible to avoid. What you need to know is if they are too big or if they are growing too fast. This simple strain gauge basically just has one part glued on the left and another part glued on the right. If it's aligned so that the markers are centered on day 0, it'll be easy to measure how far they have moved apart in a month's time, say. I mean, that's great, but we're actually wanting to look into a fully electrical strain gauge, one that uses resistance wires. This is going to give us the advantage of being able to be placed in a remote location and also allow data logging. We can also make them really small and really sensitive. So, consider this copper wire. Now I know wires are usually round, but they don't have to be. The wire has a certain resistance, R. If the copper wire is stretched, what will happen to the resistance of the wire? Give an answer and try to fully explain it. Well, the length increases, and since R equals rho L over A, that will cause the resistance to increase. But that's not the only thing. What about the area? Now we should always assume the volume stays constant, so with length increasing, the area is decreasing. That's okay, this also increases resistance, so the resistance of the wire is going to go up quite significantly. So all we really need is a long piece of wire and connect it up with a voltmeter and ammeter to monitor its resistance. Could use an ohmmeter, which is basically a voltmeter and an ammeter. The only problem is, well, the size. So to solve that problem, we simply fold the wire backwards and forwards, like so, and this means we get a lot of length along one axis. So if we do that quite small, we're going to get something folded up. It's going to be pretty delicate though. So we need to put it on a plastic backing and quite probably seal it in too so it does not get scratched or oxidized. The common way to make these then is to print the metal wire onto the plastic, which gives us a rectangular cross section for the wire. If we then take this and simply glue it onto the object that we want to monitor, as the object deforms, it will make the strain gauge deform as well. And that's going to give us our readings. As well as testing structures like I showed, strain gauges can be used to help control robotic arms or other types of movement. As the arm bends, it stretches the strain gauge, so after some calibration, that's going to let the computer know exactly what angle the arm is currently at, so it can precisely move the arm. So that covers the structure, physics and uses of a metal wire strain gauge, a device that is used in countless applications around the world to help keep our structures safe.